So today's topic is nucleophilic addition reaction. So here the addition partner will be nucleophile. Earlier we have seen electrophilic addition. So electrophile is going to add to the double bond, okay, so that it will be going to result into the product of what addition product, okay. So here carbocation then nucleophile. So first addition agent will be electrophile, okay. So that's why they are said to be electrophilic addition reactions, okay. Now in nucleophilic addition reaction, so nucleophile will be going to attack, okay. So where electrophilic addition reactions, the attacking species is electrophile, which is electron deficient, and this is opposite, electron excess. If the attacking species is nucleophile, which is electron excess, it must be electron deficient. So generally, carbonyl carbon will be going to happen. Okay. So when a carbonyl carbon is treated with a nucleophile, okay, a carbonyl carbon treated with nucleophile, it will be going to result into the addition product. Okay. So this type of reactions are called nucleophilic addition reactions. Okay, nucleophilic addition reactions. So in the nucleophilic addition reactions, where the carbonyl, if it is electron deficient, okay, if the carbonyl carbon is electron deficient, it will be more readily attacked by the nucleophile. Okay, so this is condition number one. Okay, where if nucleophile is more electron excess, then also nucleophile will more readily going to attack, okay. So the speed of the reaction depends on these two. So if it is carbonyl is more electron deficient, carbonyl carbon is more electron deficient, then the reactivity will be increases. If the nucleophilicity of the nucleophile is more, then also nu- reactivity of the nucleophilic addition will increases, okay. So the question may be asked as following. So which of the molecule is going to react fast in nucleophilic addition reaction? Okay. So option A, acetaldehyde, B, acetone, C, ethyl acetate, and D, acetamide. So how can you define the reactivity of the nucleophilic addition? So what could be the answer? Here the thing is, carbonyl carbon must be electron deficient. So when a carbonyl carbon attaches to the donating groups, it will be more sufficient with the electrons. Okay. So when it is attached with the minus I groups, then it will be more withdrawing in nature. But if it is with plus M group, it's going to increase the electron density. So these are the plus M groups. Okay. So these are plus I groups. Okay. So here it is only one plus I group. So among all these, this will be least supported in terms of electron density to the carbonyl carbon. So it is going to react faster when compared to all other molecules. Okay. So based on the withdrawing nature or based on the electron density, the reactivity will be defined. Okay. So this question asked in BHU and HCU. Okay. So one of the important comparative question. Okay. So you need to see what? You need to see the supporting groups and withdrawing groups. Okay. So if the withdrawing groups that are attached to the carbonyl carbon are more efficient in withdrawing the electron density, then nucleophilic addition will be more because the carbonyl carbon readily takes up the electron density from the nucleophile. Okay. So similarly, next options, benzoylate and 4-nitrobenzoylate. Next, 4-cyanobenzoylate and option B 4-methoxybenzoylate. So benzoylate, 4-nitrobenzoylate, 4-cyanobenzoylate, 4-methoxybenzoylate. So which is the most reactive towards the nucleophilic addition reaction? Sidhu? So among these, uh, methoxybenzoylate is a plus M group which will supply the electron density. Okay. So here the four that are given options are, let me draw the structures. So benzoylate. So reactive point will be carbonyl carbon. So next 4-nitrobenzoylate, next 4-cyanobenzoylate, next 4-methoxybenzoylate. So which is most electron withdrawing group among all these? Nitrocyanomethoxy. So which is most electron withdrawing group? So nitro is going to withdraw the electron density. Okay, it will withdraw the electron density. Cyano also withdraw the electron density. So when it feels the deficiency of the electrons, so it can accept the electrons more readily. Okay, so nitro will be going to give faster reaction or more reactivity in nucleophilic addition reaction. So if I take the decreasing order, this is the highest reactive. Okay. Next, cyano is second withdrawing group. Okay. So this one. Next, methoxy is donating, and this is without donating. So this will be the third reactive. So this will be the least reactive because it's going to give the electron density into the ring as well as the onto the carbon. Okay. So resulting into increase of the electron density on the carbon, which reacts less with the nucleophile. Okay. So we'll see some other types. So increasing order of reactivity towards nucleophilic addition reaction. So acetaldehyde, so fluoroacetaldehyde. 2 dichloroacetalate. 2 trinitroacetalate. So which will be more reactive? So ఏది ఎక్కువ రియాక్టివ్ ఉంటుంది? Is it? Okay. Is it visible now? Is it visible now? Okay. So among these four, which will be more reactive towards nucleophilic addition reaction? Yeah, D, because it is with the most withdrawing groups. Okay. So reactivity is the question that is most repetitive from the nucleophilic addition reaction. Okay. So be careful. Uh, Next question. Um, hydrolysis. So if R equal to 1, so that fastest reaction happens. Option A, NO2. Option B, CN. Option C, OH. Option D, Cl. So again, hydrolysis is the one where nucleophilic addition reaction is going to happen. So hydrolysis is going to take place with the H2O. Okay. So initially H2O nucleophile will attack on the carbonyl so that it will form a resonating structure or anion. So carboxylate type. Okay. So OH, this will be plus and this will be R. Okay. So this will be going to release the H plus and that H plus will be abstracted with the O minus. So resulting what? Sorry, H plus will be released and this will be stabilized onto the carbonyl so that NH2 will be left. Okay, because NH2 is a leaving group, so resulting into C double bond O, OH and R. Okay, so after the hydrolysis, OH will attack here, H will attack here, so it's going to give NH3 and this will be carboxylic acid. All carboxylic acid derivatives, derivatives means it is amide, ester, anhydride, acid halide. These all are carboxylic acid derivatives. On hydrolysis, they will be going to give carboxylic acid again. Okay. So these all reactions, formation of carboxylic acid from the carboxylic acid derivative or hydrolysis of carboxylic acid derivatives will be nucleophilic addition reaction. Okay. So in this hydrolysis reaction, so nucleophile will be going to attack. Okay. So that will be going to result into the carboxylic acid. So if it is R is withdrawing group, for example like NO2 and Cl, then it will be more stable to make a anion as well as the to stabilize the or to attack of the nucleophile, which decreases the electron density and the carbon. Okay. సో ఇక్కడ కార్బన్ మీద ఎలక్ట్రాన్ డెన్సిటీ తగ్గితే న్యూక్లియోఫైల్ అనేది తొందరగా అటాక్ అవుతాయి. సో తగ్గించే గ్రూప్స్ ఏమున్నా కానీ ఆ కార్బన్కి అటాచ్ అయిన గ్రూప్స్ మీద ఏదైనా కానీ ఎలక్ట్రాన్ డెన్సిటీ తగ్గించే గ్రూప్స్ ఏమున్నా కానీ అవి రియాక్టివిటీ న్యూక్లియోఫిలిక్ అడిషన్ రియాక్టివిటీని ఇంక్రీజ్ చేస్తాయి. ఓకే. సో నైట్రో విల్ బి ద మోర్ సపోర్టివ్ గ్రూప్ టువర్డ్స్ ది nucleophilic addition reaction. It is nothing but hydrolysis. Okay. So examples of the nucleophilic addition reaction. So hydrolysis of ester. So if I take hydrolysis, it is H2O by H plus. Okay. So if it is more reactive, okay, if the carbonyl is more reactive or more electron dense deficient, then it will be attacked by the nucleophile directly, so that it will be going to stabilize. Okay, initially O minus will form, so that double single bond will become, and this will be going to release the leaving group. So finally carboxylic acid will be going to form. Okay. So product will be the same, but it's going to change with the reactivity of the carbon. If it is more deficient, it will be readily active. Okay, readily reactive. If the nucleophile is stronger, which is more donating, then also readily going to react with the carbon. If it is a weak nucleophile, okay, nucleophile if it is weak, it will not going to readily attack on the carbonyl. Okay, so which will not give the or which will not initiate the reaction. In such conditions, so the abstraction of H plus will activate, okay, will activate the carbonyl carbon. So that what happens, so it's going to give C double bond O H, and this become plus. Okay, so once it become the O plus, it will abstract this double bond. Okay, so it's going to become OH, and this is perfectly carbocation, which will be readily attacked by the H2O nucleophile. Okay, so these are the two conditions. If it is strong nucleophile, it will be readily attack on the carbonyl carbon. If at all, if it is not a strong nucleophile, if it is a weak nucleophile, or the carbonyl carbon is more electron density, okay, so it is not that much reactive towards the nucleophilic addition reaction, so it needs a activator. So generally any H plus or any acid will be going to activate the carbonyl carbon by abstracting the proton, then nucleophilic addition will be going to happen. Okay, so if the nucleophilic addition happening here, so it's going to give OH, OCH3, and OH, H will be plus. Okay, so H plus will be released, OCH3 and OH. Okay, so a carbon having two hydroxy groups or two hydroxy groups on the same carbon will not be stable, so it will be going to release H plus, and this is a good leaving group, so it will be leave, so it becomes C double bond OH, again acid. Okay, so this is called ester hydrolysis. Okay, so hydrolysis of carboxylic acid derivative is nucleophilic addition reaction. So this is one example. Okay, so not only this, you can just now you have seen the amide hydrolysis, so resulting into what, acid, carboxylic acid. So this is also another example of nucleophilic addition reaction. Okay, so there are some other derivatives, so which are acid halide, which is formed from the carboxylic acid. If hydrolysis of this also going to give The carboxylic acid, this is also nucleophilic addition reaction example. Okay, because H2O will be going to attack on the carbonyl, so this will be left. Okay, so next anhydride. So this is anhydride, and hydrolysis of anhydride also will be going to result the nucleophilic addition reaction. So either of the carbon is going to attack. So if two different carbonyls are there, then whatever the carbonyl which is more electron deficient, that will be going to attacked by the nucleophile. So this will be going to result into this. So OH will be going to attack. So this part will become CH3 C double bond O minus, which is attacked by the H plus, so it becomes OH, and this part will be attacked by the OH minus, so it will become this. Okay, 2 moles of carboxylic acid will be going to form by the hydrolysis of anhydride. Okay, so these are the carboxylic acid derivatives which are examples of the nucleophilic addition reaction. Okay, so mainly in nucleophilic addition reaction, it is about the reactivity. Okay, so which is more reactive, which is less reactive, that kind of questions will be going to repeat in the examination. If not, there will be the questions like stereochemistry based. Okay, that we will be going to see. So stereochemistry based questions, for example, CH3 C double bond H. Acetaldehyde, if it is treated with HCl. Okay, so X, and upon H3O plus, so let me write the H. Okay, so that I can decrease the difficulty. So when it is H plus and Cl minus, this is a kind of nucleophilic addition reaction. Why not electrophilic? Means this is a carbonyl carbon which is electron deficient, which will be attacked by the nucleophile of the cyanide, so resulting into CH3 CO minus. Okay, this bond will move towards this O minus and Cl. Okay, and H. Okay, so this is going to abstract the H plus from this, so it becomes OH. Okay, so if it is hydrolyzed, Cn will become carboxylic acid. Okay, whenever cyano group is there, if it is hydrolyzed, it's going to become carboxylic acid. Okay, carboxylic acid. So this acid is said to be lactic acid. Okay, lactic acid. So the question is, here it is going to give X. Okay, so what is X? Option A, plus lactic acid. So this is about the optical activity. Option B, minus lactic acid. Option C, racemic lactic acid. Option D, none. Okay. So racemic means it will be indicated as plus or minus. Okay. So here, so this will be X will be given. Let's say this is A. A is given as an intermediate. Okay, and final product X is given. Okay. So if you can consider, it will be going to give the cyanohydrin. This is called cyanohydrin. Okay, cyano means Cn, hydrin means hydroxide. So cyanohydrin. So whatever the cyanohydrin that is forming will be in two kinds, because if I consider the carbonyl carbon, okay, if you see stereochemistry, carbonyl carbon is a planar one. Okay, because it is sp2. So when it is planar and attacked by the cyanide, it can attack from the above the plane. Okay, it can attack from the below the plane. Okay, so when it is attacked from the above the plane, Okay, so it's going to give cyanide as above, and this become C double bond O will become into the OH. So this will be below this one. Okay, so hydrogen and CH3 on this one. If it is attacked from the below, so hydrogen CH3, cyanide will be below the plane and OH will be above the plane. Okay, so the thing is, this is a carbon center which is having four different groups. If this is the case, it is said to be chiral carbon. Okay, chiral carbon. Whenever chiral carbon is forming from the planar compounds or achiral carbon, which is not chiral, which is not having four different groups. Whenever achiral carbon is converting into chiral carbon, there will be a two isomer formation or there will be enantiomer formation in racemic mixture. Okay, in racemic mixture. So whatever the compound on cyanide attack, if it is achiral and forming the chiral compounds, then it will be going to give racemic mixture. Okay, if it is not forming chiral center, then there will be only one kind of product. If it is forming new chiral centers, then it will be two products which are enantiomers. Okay, so this is one of the important questions asked in many examinations. So whenever a cyanohydrin is forming, there will be two kinds of cyanohydrin formation which are enantiomers to each other, which will be formed in racemic mixture, means which are equal 50 is to 50 or 1 is to 1. Okay, so optical active isomers will be forming 1 is to 1. Okay, so if this is the case, it will be 2, and resulting on hydrolysis also 2 plus and minus. Okay, so which will be depends on the experimental condition. So plus isomer and minus isomers will be depends on the experimental condition, that is what optical rotation basis. Okay, so which will be deeply studied in stereochemistry. Okay, so you need to remember that whenever new chiral center is forming, there will be a racemic mixture formation or there will be a combination of enantiomer production. Okay, so this is very important. So based on this, we will be going to see some more questions. So question: which of the following compounds on addition of HCl will result racemic cyanohydrin formation? Option A, propionate. Option B, acetone. Option C, acetaldehyde. Option D, 2-butanol. Option E, A, C, D. So what could be the answer? So here you need to see the chiral center formation. If on cyanohydrin formation, if it is chiral center is going to generate, so Cl minus will attack. So if it is chiral center generates, it will be going to give two molecules. If it is not chiral center, if it is not the carbon which is not having four different groups, then it will not give two isomers, it will give only one isomer. Okay. So let's see cyanide attack and this become O minus and H and this is Cl. Okay. So H plus will be attacked by the O minus, it become OH. So this carbon center is having one, two, three, excuse me. So four different groups. So when it is having four different groups, it is a chiral center. Okay. So if it is a chiral, it's going to give two molecules which are in racemic mixture. So this is going to give racemic mixture. Okay. Next, if this is attacked by the Cn minus, so it's going to become O minus and attacked by the OH. So resulting in what? OH and Cn. So how many different groups it is having? 1, 2 and 3. This and this are same. So it is having only 3 different groups. So which is not a chiral. So it will not give 2 isomers. Okay. So if this is the case, it will become O minus and this will be attacked by the Cn. Okay. So again it becomes OH. So resulting in the what? OH Cn. Okay. And this is hydrogen. So methyl hydrogen OH and Cn. So four different groups are there. This is chiral center. So it's going to give racemic mixture. Okay. Now this one. So it become OH and become Cn. So 1, 2, 3, 4. So four different groups are there. Again it is going to give racemic mixture. So B can give, D can give, sorry, B cannot give, C can do and D can do. So A, C, D will give racemic mixture. Okay. So B will not. Okay. When the carbonyl having two different groups around it, okay, are this is said to be symmetrical because both the sides it is same. So when a carbonyl which is unsymmetrical, okay, when a carbonyl which is unsymmetrical will give racemic mixture. Is it clear? So next type. No. So not only hydrolysis of the carboxylic acid derivative, addition of alcohols, addition of alcohols to the carbonyl carbon also nucleophilic addition reaction. Okay, if this is the case, alcohol nucleophile will be going to attack. Okay, so it's going to become O minus and R or H will be attacked. This become plus. So H plus will be released, which will be abstracted by this. So OH R O R. Okay. So this is called. It is started from the ketone. So hemiketone. Okay. Hemiketone. So ketone is the starting point for the alcohol addition. This is called hemiketone. Okay. So if it is 1 mole, another mole of alcohol is attached onto the same system. Okay. So OH will be leaving. Okay. So it's going to become R O R R O R. Okay. So this is called ketol. Okay. So addition of two alcohol molecules to the carbonyl will result. Okay. Addition of two alcohol molecules to ketone will result ketone. If it is one alcohol molecule addition to the ketone, it is hemiketone. Okay. The same reaction if it is started from the aldehyde. So this is also nucleophilic addition reaction. So ROH will be going to attack. So this become minus So R, O minus, and OR, H, and this is hydrogen. Okay. So this become plus, so it will be left and it will be abstracted. So the same thing will be going to happen. So OH, OR, hydrogen. Okay. So this is said to be hemi. This is from the aldehyde, no? So it is acetal. Okay. So if it is from the aldehyde, it is acetal. If it is from the ketone, it is ketone. Okay. So another molecule of alcohol can also be reacted. So if that is the case, OH will be left as H2O. So OR and this is plus, and OH minus and this H plus will be going to give H2O. This will become OR, and this is also become OR, and this is hydrogen. So this is called acetal. Okay. So in your BSc level also this reaction is there. Formation of acetal and ketols that were repeatedly asking in your examination also. Okay. So here in this case it is asking for the ketol formation or what kind of reaction it is. So it is a nucleophilic addition reaction. Formation of acetal from the aldehyde, formation of ketol from the aldehyde is a nucleophilic addition reaction. Okay. So try to write down or take a screenshot and write a clear note. Okay. Because these are very important reactions that will be repeated in different examinations. Okay. Once you are perfect with the types of reactions, you will be going to cover up to 40 to 50% of the syllabus of the organic chemistry, because almost all basic reactions will be covered in the types of reaction. Okay. So you will feel comfortable with the organic chemistry once you are very much efficient in the types of reaction. Okay. So try to write the products. Acetaldehyde treated with methanol. So X, and again treated with methanol, and Y. What could be the structures of the X and Y? Okay. Similarly, cyclohexanone is treated with ethyl alcohol, 2 moles. What could be the product? So, are you able to do, or shall I explain one? Okay. So, if I take this one, so it is acetaldehyde, will be upon reacting with methanol or alcohol will be going to give hemiacetal first. So, this will attack and this become this. So, O minus and OCH3, and this is H. This is plus. Okay. So H plus will be moved towards the O minus, and this is what hydrogen. So it becomes OH, H, and OCH. Okay. So this is what X, which is hemi acetal of acetaldehyde. Okay. So simple hemi acetaldehyde. Okay. Hemi acetaldehyde. So one more molecule of methanol, if it is reacted, so it is going to attack and again carbon and carbon, which is electron deficient. So OH minus will leave. So at that place OCH3 will come and resulting in what? Acetal. Okay. Acetal of the acetal. Okay. Similarly, if it is ketone, it's going to add 2 moles, it's going to give ketol. Okay. Ketol of cyclohexanone. So you need to write that product and submit in the group. So next example, we will be going to see nucleophilic addition reaction resulting into the cyclization. Okay. So in the last class we have seen the NGP formation. Okay. So now there is similar kind of reaction which are going to give the cyclic product. Okay. So option A. So this is single bond and this is white. So what could be the product? So in these cases, you need to write the mechanism. So identify the electrophile and the nucleophile. If you can do that, your half of the job is over. Okay. So here OH can act as a nucleophile because it is having lone pair. Okay. Is it clear? So OH is a nucleophile which will donate. And the carbonyl which is having electron deficient carbon can act as an electrophile. So nucleophile will be going to attack on the electrophile because carbonyl can be attacked by the electrophiles that you have already seen for the formation of esters and ketones. Okay. So on that basis, if it is attacked, it will be going to give 6-member ring. 1, 2, 3, 4, 5 and 6 because it is attacking on this. So write a 6-member ring. Okay. And start from the oxygen. Let's say this is oxygen. So with the attack of this, it become O minus. That will be supplied by the H plus of this. Okay. So this is OH plus, and this is the carbon that is attacked, which is having carbonyl become O minus. So this will attract the H plus, so resulting into what? So the final product will be D. Okay. Is it clear or shall I need to repeat? Okay. So we'll see some more examples. H plus, what could be the product? Option A. So what could be the product? Yeah, it is B. Okay. So some more workouts based on this. not only OH, NH2 can also act as a nucleophile. So then that is also going to form the cyclic products. Okay. So if this is the case which is more nucleophilic, that will be going to attack on the carbonyl more faster. Okay. So this is about the nucleophilic addition reaction. Okay. So tomorrow we will be going to see addition of Grignard reagent. Okay. Grignard reagent. So we will see different kinds of the additions and different products based on the Grignard type. So work out all this. Okay, and other examples also. So tomorrow we will discuss the some other nucleophilic addition reaction. Okay.